Alright, next one. It's going to be another binomial. That means if it's a binomial, it's only going to have two terms. And we're going to do a sum or a difference of cubes. So right down here at the bottom, make yourself about that much room. You don't need a lot. I want us to get those first 12. I don't even know that we'll need that many, but we're going to go with that. The first 12 perfect cubes. I just want you to understand what your cubes are. Because if you know them, you will recognize them and it'll make this a little bit easier. So 1 cubed is obviously 1, and 2 cubed is 8, and 3 cubed is 27, and 4 cubed is 64. That's just multiplying it times itself 3 times, raising it to the third power. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1,000. 11 cubed is 1331. We're going to stop at 12. 12 cubed is 1728. You need to be able to recognize these so that you don't have to struggle with anything. So, get you a straight edge or side, whatever, or if you're not that particular, just draw a line and split this. I'm using my handy dandy fingernail file again because this is what I have handy. So I'm going to split this down the middle, and I'm going to do a sum on one side and a difference on the other. So we're going to start at the top, way up here. A sum of cubes. Sum means that you are obviously going to add, and this is going to be a perfect cube. Sorry about that. And this is going to be a perfect cube. So it's a cube plus a cube. And it's just a pattern, really. Like, it's really just recognizing a pattern. And if you know the cubes, then you also need to know the cube roots. And so here's what it looks like. If I have a perfect cube plus a perfect cube, you're going to set up two sets of parentheses. One is going to be a binomial. The other is going to be a trinomial, 2 terms, 3 terms. You got to know those cube roots. So the cube root of this one, the cube root of a cubed is a. The cube root of b cubed is b. We'll worry about signs at the end. For the first term in my trinomial, you square this one. You multiply these two things together, and you square this one. And your signs, if this is a plus, then your signs are plus, minus, plus every time. So let's do a couple so you can see what I'm talking about, because these are not hard. I might even split this into 2 videos so you don't have to have a very long lesson on this. Sum of cubes. If I've got 8x cubed plus 1. Binomial times a trinomial. Perfect cube plus a perfect cube. Take the cube root of 8x cubed. Take the cube root of 1. All I did is take cube roots. Now you take this whole thing, the 2x, and you square it. You multiply these two things together. You square this one. And your signs are plus, minus, plus. It doesn't always start out looking like what you want it to. That is not a perfect cube. That is not a perfect cube. But this tells me that maybe I might have something going on here. Check for a greatest common factor. I can take out a 2. Now I have a perfect cube plus a perfect cube. Just like with everything else, you cannot leave that greatest common factor off of your answer. You keep dragging it along. A binomial times a trinomial. Take the cube root of 8. Take the cube root of 125a cubed. Square the 2. Multiply these two things together. Square the 5a. The signs are plus, minus, plus. Some of you already have it. You don't need me anymore. I'm going to do 2 more and I'm done with this one. because I try to show you a little bit of everything that I possibly can. If I have this, if that lead term is negative, probably can factor out a negative, and if I had a greatest common factor, and I do, I need to take that out too. So the biggest thing I can take out of negative 32 and negative 108 is negative 4. That's going to leave me with 8m cubed, and this comes back to knowing your cubes too, because I already know that 8 is going to go into 32, and 8 is a perfect cube. I know that 27 is going to go into 108, and that's a perfect cube. When you factor out a negative, it changes the signs. Now I have a sum of cubes. A binomial times a trinomial. Take the square root. Take the square root. I'm sorry, the cube root. I said square, I meant cube. You take the cube root of 8m cubed, the cube root of 27. Here's where the square comes in. You're going to square the 2m. You're going to multiply the 2m and the 3. You're going to square the 3. The signs are plus, minus, plus. I think you got it. I'll show you one more just for the fun of it. So perfect cube plus a perfect cube. If you're not sure, you can use your calculator to take the cube root. If you don't know them and you're not positive, you can do this. Hit the 3, second, hit this button because that's your cube or your nth root, and then take the cube root. Hit 7. I'm going to be lazy and go back up and grab that and change that to 1331, and the cube root is 11. So binomial times a trinomial, the cube root of 343x squared is x cubed, is 7x. The cube root of 1331 is 11. You square the 7x, you multiply the 2 together, you square the 11. Your signs are plus, minus, plus. That's it. That's all there is to it. Since I'm only 7.5 minutes in, I'm going to go do the difference. It's going to be the perfect cube minus, because that's what subtraction means. That's what difference means. It's exactly the same, except you have to deal with the signs differently. You're going to take the cube root, you're going to square it, you're going to multiply, you're going to square it, but your signs are going to be minus, plus, plus. That's what it's going to take for you to use your distributive property and multiply everything back out and end up with just this. If you don't believe me and you want to do your little box method and do this times this and make sure I'm not lying to you, do it. Or believe me. It's up to you. So here we go. That's probably a bad option for, or a bad outlook for me to do. Okay, interrupted. Anyway, here we go. So here's my example. I don't even know what I was saying. Oh, I was saying that was probably like a lazy attitude for me to say, go and do your little box method, multiply that out and check it. Or you can just trust me when I should probably just show you, but we're going to just trust me because I would never intentionally lie to you. I might be wrong, but I wouldn't be wrong on purpose, and I wouldn't be lying because then it would be an accident, right? Okay, so difference of cubes, a perfect cube minus a perfect cube. So here's what we got. A binomial, a trinomial. You take the cube root. You take the cube root. You square it. You multiply. And you square it. And your signs are minus, plus, plus. Let's see it again. Perfect cube, that's 216, x cubed. My sixes never look like sixes. I don't know why. 216 x cubed minus 8. Is that a perfect cube? It is. Is that a perfect cube? It is. if you want to check for a greatest common factor, and the reason I'm pausing right here is I'm like, ooh, those are both even. I can probably take something out of that, and let's see if it'll help me or hurt me. I can take out an 8. Let's see, 8 will go into 216, 27 times, and 8 will go into 8 one time. Okay, I still have a perfect cube minus a perfect cube. So, keep that little greatest common factor. Binomial, trinomial. Take the cube root. Take the cube root. Square it. Multiply it. Square it. Minus, plus, plus. Let's do another. 125x cubed minus 512. I don't see a greatest common factor there. No. So perfect cube minus a perfect cube. Binomial, trinomial. Cube root. Cube root. Square it. Multiply it, square it. Be careful that you don't put 16 or 10x squared because you're multiplying it by itself, you're not adding it. So be careful with that. Those are easy mistakes in your signs. If this is subtraction, then it's minus, plus, plus. Last one, and we're done with this one. And I'm going to do it. I did this one. I picked this one intentionally. Oh, sorry. Ugh, I don't know what I just did. That's plus 54. So that's a negative 250x cubed plus 54. Obviously, they're both even, so I can take something out of that. And that lead term is negative. So let's pull out the negative. Let's take out a negative 2. That should do it. And that's going to give me 125x cubed minus, because if you take out a negative, it changes the signs, minus 27, perfect cube minus the perfect cube. So binomial, trinomial, right small right here, sorry. So take the cube root, square it, multiply it, square it. The signs are minus, yes. Minus, plus, plus. I just made myself pause and think. Your signs are minus, plus, plus. That's it. That's all there is to that.